Hello and welcome back to Learning with the Fosters. Today we're going to go over our homework from our lesson regarding absolute value and the distance on the real number line. Our location today is the future home for the ARC Animal Resort and
Retreat.
One of our newest projects we're going to be working on, a retreat, an animal resort. Okay, so to the math. Our first task was to evaluate these expressions, absolute value expressions, but explicitly deal with the algebraic definition that we talked about for absolute value. That is, the absolute value of A is equal to A, red A, if A is greater than or equal to 0. The absolute value of A is equal to negative A, that is green negative A, if A is less than 0. So for these first few ones, we'll explicitly write that out. And again, we talked about geometrically what's going on as well, as the absolute value is the distance from a number A to 0. So this first one, negative 13, let's evaluate this. So our first thing we have to look at is, let's write what is our A. Our A is what's between the absolute value, so in this case, negative 13. That will help us as we substitute into our definition. So now, the absolute value of A is equal to which one of these two conditions will we follow? Well, we have to look at A. Is A, negative 13, greater than or equal to 0? No, so it's not going to be red A, rather it is less than 0. So the absolute value of negative 13 is going to be equal to negative A. So it's equal to negative. And what is our A? Is it 13? No, it's negative 13. Okay, remember, use parentheses when you're substituting. So what is a negative 13? Well, that's a positive 13. And that's good, because remember, absolute value is always greater than or equal to 0. Because geometrically, that corresponds to distance, and distance is always greater than or equal to 0. So the absolute value of negative 13, using our algebraic definition, is 13. Let's look at 101 over 7, a nice rational number. What is our A? Well, our A is 101 over 7. So, is our A greater than or equal to 0? Yes, it is. So the absolute value of A will be equal to simply A. What is A? 101 over 7. We can drop the parentheses. So the absolute value of 101 over 7 is 101 over 7. How about negative absolute value of 27? Now we have to be a little bit careful on this. This will help to denote what A is. Is A negative 27 or is A 27? Well, A is what is within the absolute value bars, remember? So the absolute value of A is between the absolute value bars. So this negative sign is external to that. So we have to look at A is 27. Okay, so the absolute value of A, is it A or is it negative A? Well, 27 is greater than or equal to 0. So the absolute value of 27 is A. 27. But we're not done yet. We have this negative sign that needs to be brought down. And so now we can see we have a negative 27. And again, remember, there's kind of an implicit negative 1 multiplied to that 27. So a negative times a positive is a negative. So our final answer for this expression is negative 27. Now notice we're not saying that the absolute value is negative. Rather, we're saying the negative of the absolute value of 27 is equal to negative 27. A little bit tricky if we mistake our negative signs and what's really going on. All right, let's look at this one. We have a negative absolute value of negative 62. Something similar as to this one, where we have an exterior negative sign. So let's deal with our absolute value first. Remember, order of operations, absolute value acts like parentheses or brackets do, grouping symbol. So we have to deal with inside that first. So what is our A? Our A is between the absolute value bars, so negative 62. Okay, let's evaluate the absolute value of negative 62. Well, negative 62 is certainly less than 0, so the absolute value of negative 62 will be negative A, or negative a negative 62. So our A is negative 62. And what is a negative times a negative? A positive 62. So the absolute value of negative 62 is a positive 62. But again, we're not done yet. We have this negative sign to bring down. A negative times a positive is a negative. So again, like we have here, a negative 62. So from here on out, we won't explicitly write out or evaluate these using the algebraic definition, but we'll expect that we understand both algebraically and geometrically with what is going on with absolute value. But from here on out through the homework, we'll simply be able to recognize that the absolute value of negative 13 is going to be positive 13. The absolute value of 107 over 7 will be 101 over 7. So let's evaluate these expressions. Here we have the absolute value of negative 2 to the third power. So we work within our grouping symbols, within our absolute value first. Our thing we have to do is to evaluate this exponent to simplify it. So for this example, we'll write this out. So again, what is negative 2 to the third? Well, I hope you have it memorized or can compute it in your head at this point, but we'll write it out explicitly, at least for this example. Here's our base. Here's our exponent, so we have 3 factors of negative 2. There's negative 2, okay. This again is equivalent to this. So let's evaluate these. Negative 2 times negative 2 is a positive 4. Bring down everything else. A 4 times a negative 2 is a negative 8. Absolute value of negative 8 is a positive 8. Positive 8 is the answer. All right, this one's a little more involved. We have 2 sets of absolute value going on, each with some operations in between, so this one should be fairly exciting. Remember, absolute value act as grouping symbols, so we will start with moving left to right. Well, let's work on this absolute value. Now, 16 over negative 4, we can simplify, right? Or we can divide. We can look at this as 16 divided by negative 4, or simply simplify 16 over negative 4. So let's do that operation before we deal with the absolute value. So what is 16 divided by negative 4? Well, a positive divided by a negative is a negative. Let's bring everything else down. Absolute value of negative 4 is a positive 4. Got that absolute value taken care of. Let's bring everything else down. Now we can work within this absolute value bar before we take the addition of 4 plus this quantity. So we have an addition and we have a multiplication. We deal with multiplication first. 6 times a negative 2 is a negative 12. Bring down the rest. All right, we've got a 3 plus a negative 12. Well, that's a negative 9. The absolute value of which plus 4. All right, before we take 4 plus negative 9, we have to do what? Evaluate the absolute value first. The absolute value of a negative 9 is a positive 9. And now we are close. We have one operation left, a 4 plus a 9, which is a 13. All right, very good. This one is relatively simple, at least compared to this last one. We have the absolute value of 8 minus 12. We'll evaluate 8 minus 12 first. That is a negative 4. The absolute value of a negative 4 is a positive 4. Very good. All right, moving right along. One more of these to evaluate. Here we have some embedded absolute values. So again, these are like grouping symbols, so we start with the innermost ones. So the first thing we have to do is evaluate this absolute value of negative 20, which of course is a positive 20, and we can understand geometrically and algebraically where that comes from by this point. Let's bring everything else down. All right, next thing we evaluate is absolute value of negative 50, positive 50. Bring everything else down. 20 minus 50 is a negative 30. And one thing left to do is to take the absolute value of negative 30, which of course will be a positive 30. And there we have it. All right, we'll continue evaluating expressions, but now we'll have some practice working with substitutions. Here we're given the values where a is equal to 5 and b is equal to negative 3. So first thing we have to do, of course, is to substitute our values in and then evaluate. Now, when we substitute in, we always do what? Make sure we use parentheses to avoid error. So the first thing we have to do is let's substitute our values in. A squared, which is 5 squared, plus 10 times b, which is negative 3. And we're taking the absolute value of that whole expression. All right, working within the absolute values, we deal with our exponents first. So 5 squared, or 5 to the second power, again is 5 times 5, which is 25. Okay, next thing we do, not addition, we do multiplication. 10 times a negative 3 is a negative 30. Again, we're taking the absolute value of this whole thing at the end. All right, now we have a 25 plus a negative 30 is a negative 5. And the absolute value of negative 5 is a positive 5. So very good. So this whole thing simplifies to a positive 5. Not too bad. Let's check out this one. Again, first thing we'll do is substitute in our values. So we have 2 times b, which is negative 3, minus 2 times the absolute value of b, again negative 3, over the absolute value of a, 5 times b, which is negative 3. All right, now we have a fraction bar. We've got absolute values. Remember, we're going to work above and below the fraction bar. So let's first deal with our numerator. All right. First thing we need to do is take our absolute value of negative 3, which is a positive 3. Okay. Now we've got 2 multiplication items left. We'll start left to right. 2 times a negative 3 is a negative 6. And then we minus a 2 times a 3. Next thing we do, take a 2 times a 3, positive 6. We have a use white chalk. Negative 6 minus a 6. Negative 6 minus another 6 is a negative 12. Okay, so that simplifies to negative 12 for the numerator, but now we have to look at our denominator. So I guess we'll have to erase this later. We'll work over here. We have the absolute value of 5 times a negative 3, or a times b, given those values. 5 times a negative 3 is a negative 15. The absolute value of a negative 15 is a positive 15. And there is our new denominator. So let's put these together. We have a negative 12 over a positive 15. Well, that's a perfectly good rational number, but we can simplify it. And of course, we always want to get in the habit, or most of the time get in the habit of doing so. If we divide both by 3, we get negative 4/5. And there is our final simplified answer. Let me erase this so we have some room to work with over here. One more to go. Let's first substitute in our values. I'm going to write it over here so we have enough board space. So we need to substitute in 1, the absolute value of a, which is 5, over the absolute value of 7 times b, negative 3, minus b, negative 3, times the absolute value of a, 5, minus b, negative 3, squared, and absolute value. You see I kind of merged into that, so I'm going to erase this for clarity so we don't get distracted. Okay, here's our substituted problem. Now we can simplify. Let's deal with the numerator first. A negative absolute value of 5. We've seen this already. Absolute value of 5 is 5. Bring down the negative. We have a negative 5. Our new numerator is negative 5. Again, the absolute value is positive, but this negative makes the final product negative. All right, let's deal with the denominator. We've got multiple operations going on, multiple absolute values. We'll start with this one and work this way. Again, we're working above and below the fraction bar. So 7 times a negative 3 is a negative 21. All right, absolute value of a negative 21 is a positive 21. All right, now we can deal with inside this absolute value. So we've got a 5 minus a negative 3 to the second power. So of course we're going to have to deal with that portion first. We simplify our exponents first. So negative 3 to the second power, or negative 3 squared, is negative 3 times negative 3, positive 9. And again, remember we looked at in our lesson where we kind of reviewed exponential notation. When you have a negative base to an even power, it's going to be positive. A negative base to an odd power, it will be negative. All right, still working within our absolute value. We have a 5 minus a 9 is a negative 4. Look, we're getting closer though. The absolute value of negative 4 is a positive 4. And again, just for review, we do the absolute value before we take this multiplication, because the absolute value is like a grouping symbol. All right, so now we have 21 minus a negative 3 times 4. We take negative 3 times 4 first. Gives us negative 12. 21 minus a negative 12. Okay, let's think about this. We're at 21. We're going to subtract but we're subtracting a negative, so we're moving in the positive direction. So it's essentially 21 plus 12, which is 33. All right, so there is our new denominator. We can combine our results from our simplification of the numerator with this to get negative 5/33. And that's as simple as we can get that. So there's our answer. Let's continue on. All right, we moved out of the shade a little bit. We've got one more of these using our a equals 5 and b equals -3. We have the absolute value of a times the absolute value of b over the absolute value of a times b. All right, first thing to do, of course, is to substitute our values, and then we'll simplify. But wait, perhaps you've noticed a shorter way we can do this problem, using some of the identities of absolute value we looked at. What do we notice here? Our numerator and our denominator are equivalent statements. Remember some of our properties that we looked at? The absolute value of a times the absolute value of b is equal to what? The absolute value of a times b. Or in other words, our numerator is equal to our denominator. Well, if they're the same, what is something divided by itself? 5 divided by 5, 10 divided by 10, 11 divided by 11, a divided by a. Well, it's 1. With the exception of 0 over 0, that's kind of a different story. But these are not zeros, so we can be very safe to say that the answer to this is 1 without substituting, without evaluating, simply by recognizing that the numerator and the denominator are equivalent because of our properties of absolute values that we looked at. So we can say that the answer is 1. But just for confirmation and for practice, let's go through and do substitute and see if we get the same answer. So we'll substitute in our values. The absolute value of a times the absolute value of b, where a is 5 and b is -3, over the absolute value of a, 5, times b, -3. All right, let's go through and we'll deal with the numerator first. All right, the absolute value of 5 is 5. The absolute value of -3 is 3. 5 times 3 is 15. So our numerator is 15, so our bottom should be 15 if we were correct in our initial judgment. So let's work with the denominator. We'll just continue working down. 5 times a -3 is a -15. Take the absolute value of that, a +15. Okay, good. So we can combine our two results. We end up with 15 over 15, which is equal to 1. Which is exactly what we noticed at the beginning. See how nice it is to identify those properties. Okay, Val, so we're going to go through these properties. Thanks for the tip. All right, Val just gave me some tips on these properties. So our goal on this portion of the assignment was to state whether these are true or false, and do so using the properties of absolute value that we looked at in the lesson. We looked at 5 of them. So this first one, this is similar to what we saw on a few examples ago. Is this a true statement? The absolute value of x over the absolute value of y over the absolute value of x over y. So kind of embedded fractions here. Is that equal to 1? Well, we don't have any values for x or y to think of, but if something's going to be equal to 1 and it is in a fractional format, we know that these two would have to be equivalent for it to be equal to 1, right? And our little other kind of qualifier with this problem is is that x and y cannot be equal to 0. Well, why could x and y not be equal to 0, Val? Well, let's take y. If y was equal to 0, what do we have? We remember we can't divide by 0. So it's undefined. If y is 0, then this fraction and this fraction, and then by default, the whole fraction together is undefined. Well, what if x is equal to 0? Well, we can take 0 divided by some other number, as long as it's not 0. So that's no problem, but what happens? 0 divided by any other number is going to be 0. What we end up with, if x is 0, is 0 over 0. Now, this initially looks like it should just be 1, because it's the same number divided by the same number. But it's not quite that simple. Again, we see that the denominator is 0. You can't divide by 0, so this is really not defined either. So x and y can't be 0, but they can be any other real number. For this statement to be true, to equal 1, we'd have to say that the numerator and the denominator are equal. Again, 7 divided by 7 is 7. 7 divided by 7 is 1. Q divided by Q is 1. 1,000 billion gazillion divided by 1,000 billion gazillion is 1. So the question really to ask on this is the absolute value of x over the absolute value to y equal to the absolute value of x over y? Well, we could choose real numbers as long as they're not 0 and kind of test these out, kind of as we did with the lesson. Or we can simply remember the work we did with properties and identify this, that it's true that the absolute value of x over the absolute value of y is equal to the absolute value of x over y. So yes, this statement is true because this is just an equivalent way of writing this. This was property number 4, if I recall correctly. So this is true. And again, this is important to remember, x and y cannot be 0. Well, let's look at this one. Is the absolute value of x plus y greater than or equal to 0? Well, x and y, we don't have any restrictions. There could be any real numbers. We could try a bunch of them out, or we could identify this as this was our property that we looked at, where absolute value is always what? Greater than or equal to 0. So whatever is going on in between these absolute value bars, eventually what this quantity is, the absolute value of that quantity will always be greater than or equal to 0. And again, geometrically, we looked at that as distance corresponds to absolute value, and distance is always greater than or equal to 0. And algebraically, we looked at that as well. So this is also a true statement based on our very first property that we looked at dealing with absolute value. How about this one? The absolute value of x is greater than the absolute value of negative x. Well, x is greater than negative x, so perhaps intuitively we would think that, yeah, this looks like a true statement. But remember, the absolute value of x will be x, because x is greater than or equal to 0. The absolute value of negative x will be negative x, which is a positive x. Or in other words, we can refer back to this property where absolute value is always greater than or equal to 0. So this absolute value, where x and negative x, even though x is positive and negative x is negative, this is not a true statement because this is going to be equivalent. Not greater than, equal to. And in fact, that's exactly how we wrote it, as this was our second property, if memory serves correctly. So the absolute value of x is equal to the absolute value of negative x. Numerically, we could choose an example. The absolute value of 6 is equal to the absolute value of negative 6, where, of course, x would be 6. Okay, so this one was false. And in order to make it true, we would have to say equals, not greater than. There's a giant ant home here I'm trying to avoid. How about this one? We have the absolute value of x times y. Is that greater than or equal to the absolute value of x times the absolute value of y? Well, we've already worked with this through some of the homework, and I hope you identified these product properties fairly easily. We looked at where the absolute value of x times y is equal to the absolute value of x times the absolute value of y. And again, we can plug in examples like we did in the lesson, or perhaps you did the same. So these are equivalent statements. So yes, this is a true statement because this allows for the greater than or the equal possibility. A better way to write it would simply be as equal to. These are equivalent statements. But this is true because of the equal to portion. And this was our property number 3. 3. 1, 2, 3, 4. Yeah. Okay. Here we have an interesting looking one. The absolute value of x plus y is equal to the absolute value of negative x plus negative y. Well, this resembles some of our other properties where it looks like they should be equivalent statements. But remember, we did some examples with these and found that when x and y were one was positive, one was negative, this wasn't true. In fact, this ended up being less than. So we noticed that it wasn't equal to, it should have been less than or equal to. If x and y were both positive or x and y were both negative, then we end up getting equivalent statements. But if x or y, one is positive and one is negative, we end up getting this side to be less than this side. Remember, this was that what we call the triangle inequality. But this isn't exactly what we had with the triangle inequality. We had just regular x and regular y. So does that change? Does this now make this an equivalent statement since we're looking at negative x, the absolute value, and the absolute value of a negative y? What do you think, Valentine? Well, we can look at this property and say it's not going to make any difference. Because remember, the absolute value of negative x will be the same as the absolute value of x. And of course, similarly with y. So although we have these negatives, which were not in our inequality we looked at, because of this property, it's not going to change anything. Right, Val? So this is not a true statement. It should be, to make it true, less than or equal to. And the immediate purpose of us looking at absolute value or reviewing absolute value is because we're talking about distance on the real number line, the distance between points and their corresponding coordinates, real numbers. So now let's turn to a few problems involving the distance on the real number line. Now again, remember, we're talking about distance between the points P and Q as being equal to the absolute value of A minus B, where A and B are the respective coordinates of P and Q, so real numbers, or the absolute value of B minus A. Now, why are these two statements both okay? Well, remember we talked about we're dealing with distance. The distance from location A to location B is going to be the same distance as traveling from distance B or location B back to location A. You take a trip from Dillon, Montana to Salt Lake City, Utah, it's not going to change mileage when you return from Salt Lake City back to Dillon. It's going to be the same. So we have W equaling 4, X equaling negative 21, Y equals negative 5, and Z equals 10. Perhaps you actually constructed a real number line and plotted these to help you. I think that would be a very good strategy. For me, pictures, visual images really help relate mathematics and help them to make sense for me. We won't do that here, but if you did that, I give you a thumbs up. Good job on that. So the distance from Y to X, or the real number Y to the real number X, those are the coordinates corresponding to the points PQ. That's our task to find. So we can use both of these formula, either one, to find this solution. So we have the absolute value of A, or in this case Y. Y is negative 5 minus B, or our X, which is negative 21. All right, I think by this point in the assignment, we're evaluating these fairly quickly and fairly without too much trouble. So we first evaluate negative 5 minus a negative 21. So if you're at a negative 5 and you subtract negative 21, that turns out to be 21 in the positive direction, or in other words, a positive 16. Take the absolute value of 16 and we come up with distance being 16. Now, at least for this first one, let's do construct a real number line just so we can kind of see this and see if it looks like it should make sense. So if we have our real number line up here, our point y, which is -5, and our, what else? We have x, which is -21. How far would it take? Well, if we're at -21, -20, -19, -18, 17, etc., and it will take 16 units or miles or whatever we're measuring in to get to -5. It'll be less than 21 because 21 would take us all the way back to 0. We're getting to -5, still 5 away from 0. So 16 is the correct answer. And again, it's positive because distance is always positive. All right, let's look at this one where we have x and w. So we will take the absolute value of our x, which is -21, minus our w, which is 4. Of course, we'll take the absolute value of that. So -21 minus 4 is a -25. Absolute value of a -25 is a positive 25. And again, on a number line, here's our -25. To get from here all the way to +4, you'd have to go 21 to get to 0. You've gone 21 and then another 4 from 0 to get to 4. So that makes sense, 25. All right, let's look at z and w. So the absolute value of 10 minus w 4. This is a little simpler. 10 minus 4, 6. Absolute value of 6. 6. And again, on a number line, you would see something similar. Starting at 10 and getting to 4, you'd have to move 6 units in this direction. All right, how about x and z? So we have x is -21 minus z is 10 All right, so -21 minus 10 will be -31. The absolute value of -31 is +31. And that's quite a bit of steps for what we're looking at. But yeah, if you started at -21 and you wanted to go to +10, you'd have to go 21 to get to 0, then another 10, that's 31. So that makes sense as well. All right, now x and y. So we have x, -21, minus y, -5. And perhaps you didn't even have to do this one, because if you notice, we've already done the pair of y and x. The distance traveling from y to x is going to be the same as the distance traveling from x to y. So we should notice it should be equal to 16, which is -21 minus -5 is -16. Absolute value is, again, 16. Remember, distance doesn't change despite the direction you're going. Very good on that. This one I think was kind of fun, just to make sure we haven't forgotten what we've been looking at throughout. Remember, math is integrative, it builds on each other. So in this case, we're given I is equal to, remember what these are? The intervals. In this particular case, we're taking the intersection of these two intervals. And we're asked to find the distance of interval endpoint A and interval endpoint B. That's just how I've chosen to denote this as we work through it together. Perhaps you came up with some other way, but to me it makes sense. And we talked about intervals in terms of A, B as the two endpoints. So I is equal to this particular interval, the intersection of these two intervals. So whatever I turns out to be, endpoint A and endpoint B, we want to find the distance. And again, remember, the distance we can take as the absolute value of our two respective points. In this case, we have pi A minus I B. And that should give us the distance between those. So our first thing we need to do is figure out what I is, or in other words, what is the intersection between the interval from -9 to 5, in which we include the endpoints, closed interval, and similarly for -17 and 2. Let's construct a number line to help us with this. All right, let's graph this first interval, -9, negative, all right, this in white, -9, and we include -9, so we use a filled in circle, and this interval goes from -9 to 5. Color this interval in orange, all points from -9 to 5, including -9 and 5. And then we have -17 to 2. This is 2, and this is -17. Again, we're including those two endpoints. Not to scale, but I think we get the point. And the intersection, again, will be the points common to both sets, both intervals. In this case, specifically here, we have the orange and red overlapping, including the endpoints. They're included within both. So our interval I is equal to the interval -9 to 2. All right. So here is our I sub A. Here is our I sub B. We can plug these real numbers into our distance formula and be able to find the distance quite easily, I think. So let's do that. We're going to take the absolute value of I sub A, which is -9, minus I sub B, which is 2. And the -9 minus a 2 is a -11. Absolute value of -11, +11. Now on our real number line, does that look like it should make sense? Well, if this is -9, if this is 2, 0 would be about here. How long will it take to get, or what is the distance from -9 to 0, or the absolute value of -9? Well, 9, the absolute value of 2, so 9 and 2 is 11. Good work. I thought that was a good one. Okay, one more. This one, the directions were Dama left Puerto Rico where the temperature was 84 degrees, and we're talking about Fahrenheit. She visited her daughter and grandkids in Montana where the temperature was a -23 degrees Fahrenheit. She then went to visit her son and daughter who live in New Mexico where the temperature was 52 degrees Fahrenheit. So we want to use absolute value to find the difference in temperature between these various locations. What is the difference in temperature that poor Dama experienced throughout her travels? So I chose to denote this as, instead of distance, we're dealing with temperature, difference of temperature. So I put the D sub T to stand for difference of temperature between PR, obviously Puerto Rico, MT, obviously Montana, and NM, obviously New Mexico. When I assign variables or notation, I like to keep it fairly standard, fairly universal, but also kind of, make it my own so I understand what it is that I'm doing, rather than these are just symbols and numbers, but what is it that we're attempting to solve here? So we're dealing with difference of temperature, but essentially absolute value measuring the distance of temperatures to 0 is the same. It corresponds to the real number line, where we can use our distance on the real number line rather than corresponding to distance in miles, corresponding to difference in temperature. So we can use our same formula and ideas that we've been using previously to work with this temperature problem. So if we want to find the difference in temperature between Puerto Rico and Montana, we can use the absolute value of the temperature in Puerto Rico, which is 84 degrees, minus temperature in Montana, a negative 23. And that should give us the difference in temperature that Damaris has experienced. All right, so an 84 minus a negative 23, well, if you got a negative 84, we're going to subtract, but it's going in the negative direction, it's positive, so 84 plus 23 would be 107. All right, the absolute value of which is 107. So look at that, the difference of temperature Damaris experienced from Puerto Rico to Montana is 107 degrees, which makes sense. Let's kind of walk backwards on the thermometer, if you will, as we do this. So if Puerto Rico is 84, to get to 0 would be 84. Then to get to negative 23, you have to go another 23 degrees in the downward, the frio direction, giving us a total of 107 degrees as the difference of temperature. All right, pretty extreme. How about between New Mexico and Montana, the difference of temperature? Well, again, we can take the absolute value of New Mexico, 52, minus Montana, negative 23. Won't be quite as extreme as Puerto Rico, but still, it will be somewhat significant. So 52 minus a negative 23 will be a positive 75, if my arithmetic is correct. Take the absolute value, 75. The absolute value of 75 is 75. So again, let's make sure this kind of makes intuitive sense. New Mexico is at 52. Have to go 52 degrees, a distance of 52 on the thermometer to get to 0. Then an additional 23 to get to Montana's temperature. And look at who's here. This is Ignacio. Hello, Ignacio. All right. So the difference in temperature between New Mexico and Montana was 75. Still quite a change. All right, now let's look at New Mexico to Puerto Rico. Well, this one shouldn't be quite as bad. Let's see how it looks. We can take the absolute value of New Mexico, which is 52, minus Puerto Rico, which is 84. Take the absolute value of that. So a 52 minus an 84 is a negative 32. Take the absolute value of negative, need my negative sign, 32. And that, of course, is a positive 32. So the difference in temperature between New Mexico and Puerto Rico is 32 degrees. So the most extreme, which makes sense, is between Puerto Rico and Montana. Next, between New Mexico and Montana. And then the closest in the difference of temperature, or the least drastic, is between New Mexico and Puerto Rico. But we can say exactly how much. One more. This is the difference in temperature between Montana and Puerto Rico. Well, we've already solved that looking at Puerto Rico to Montana. And remember, it's going to be the same. It's not going to change. It's not going to be different whether you look at Puerto Rico to Montana or Montana to Puerto Rico. So we can simply arrive at the conclusion that we did for our very first one, 107, the most extreme difference in temperature that we have noticed on here. Good job on the homework. The goats certainly enjoyed that. I hope you had a good time going through that. Look forward to seeing you next time as we continue talking about real numbers. We'll look at some of the properties of real numbers. Look forward to seeing you then. Bye.
Thank you for learning with the Fosters. This is a friendly reminder. Remember that these courses are not for free. For information of the cost of the lessons and how to pay, please visit our website. Thank you so much for being with us.